All right, guys, this is a problem that I know that none of you are probably incredibly excited about, but I do need to go ahead and review a few things for you on relative extrema. First off, you are solving for the relative extrema of this equation. If you have completely forgotten what that means, let's review a few things. First off, extrema indicates that I'm talking about a minimum or a maximum. That's called an extrema. Okay, and these are turning points on a graph. Typically, you have a graph that could be have multiple curves, and then every time the curves change direction, in other words, it goes from increasing to decreasing or vice versa, then that gives you a point of extrema. In order to locate the points of extrema, you actually have the first derivative test, which is where you take the first derivative and you set it equal to 0. This allows you to solve for your extrema. But then in order to classify the extrema and actually determine if it is a minimum or a maximum, you have to set up that chart. So we're going to go through all those things, except we're doing it with a natural log problem. So we're kind of killing two birds with one stone. All right, on this, we're going to start out by taking the derivative. Now, some of you might be getting a little confused. This is just something that I've seen in the past with students. Whenever they start taking the derivative of these problems, they immediately look at the left and see that y equals, and they think y prime over y. Remember, that's only when you're taking the derivative of the natural log of y. If I'm just taking the derivative of y, that simply just becomes y prime. If I'm taking the derivative of something that has the natural log in front of it, then I'm going to use y prime over y, x prime over x, u prime over u. So for this problem, I'm going to allow u to equal x squared plus 2x plus 3, and u prime will equal 2x plus 2. So when I'm taking the derivative of the natural log of this quantity, it's going to be u prime over u, which would be 2x plus 2, over x squared plus 2x plus 3. Okay, now in order to determine what the relative extrema are, we're now going to take this first derivative and set it equal to 0, kind of like what we talked about at the very beginning. So in order to set this equal to 0, I have to set the numerator and denominator both equal to 0 to find all of the critical numbers. When I set 2x plus 2 equals 0, life is incredibly easy because I get 2x equals negative 2, which gives me x equals negative 1, a possible critical number. When I solve for the second one, x squared plus 2x plus 3 equals 0. Be careful, you cannot factor this because it's a positive 3. So I can't factor this to x plus 3 and x minus 1. It won't work. I would actually have to use the quadratic formula. And I know that I already felt the size, but when I look at this, I'm actually going to have negative b plus or minus the square root of b squared. So that would be 2 squared minus 4ac. all over 2a. What I want you to immediately recognize is the fact that you have 2 squared, which is 4, minus 4 times 1 times 3. In other words, I'm going to have 4 minus 12 inside of a radical, okay? So that's going to give me an imaginary number, meaning I can throw this out completely. So I only have one critical number that I'm being concerned with here. Now we're going to set up the chart to determine if it's a minimum or a maximum, okay? So the chart is where you have, you can say from negative infinity to negative 1, x equals negative 1, and then negative 1 to positive infinity. Okay, and then we have f of x and f prime x. Okay, in order to determine what the critical number is or whether it's going to be a minimum or a maximum, I choose the number in one of the intervals. You guys know how much I love my favorite number ever, which is 0. So if I allow x to equal 0, that's actually going to pull it out of this interval here. But I'm going to plug it into the first derivative because I'm testing the first derivative. So if I go back and check, my first derivative is 2x plus 2 over x squared plus 2x plus 3. So coming back over here, if f prime x equals 2x plus 2 over x squared plus 2x plus 3, and I plug in 0, this is going to give me 0 plus 2 over 0 squared plus 2 times 0 plus 3, which simplifies to give me 2/3. Remember, the number itself doesn't matter. All that matters is the fact that it's a positive value. Now, x equals negative 1 does not have multiplicity, so that indicates that the left-hand side is going to be negative. You can go through and do the math for that if you would like, but it's kind of irrelevant because no multiplicity, no reason to be concerned with it. The next thing that I need to do is determine what my value is for f of x. So I know that f of x equals the natural log of x squared plus 2x plus 3. So if I'm trying to determine what my value is, I plug in -1 for x. So this would be the natural log of -1 quantity squared plus 2 times -1 plus 3. This is going to give me 1 minus 2 plus 3, which will end up giving me the natural log of 2. Sorry, that's so low on the screen. But natural log of 2 is actually going to be my value. So what can we pull away from this is that on the interval from negative infinity to -1, it's decreasing. On the interval from -1 to positive infinity, it's increasing. So I understand that at x equals -1, I actually have a relative minimum. Now, it is considered relative, not absolute, because it's on an open interval from negative infinity to positive infinity. Just a quick reminder. And specifically, it is at a value of, I'm going to move my face out of the way, at a specific value at -1 natural log 2. You could have re-specified that up here instead of saying at x equals -1. If you wanted to put at the point, that's completely okay. That's a little redundant, but all in all, that is your answer for this problem.